If secant theta plus tan theta is equal to p, then secant theta, prove that secant theta is equal to p square plus 1 divided by 2p. So this identity we will try to solve from right hand side because we have the value for p. So right hand side is p square plus 1 by 2p, and the value of p is secant theta plus tan theta. So p square is secant theta plus tan theta the whole square plus 1 divided by 2 into secant theta plus tan theta. Now secant theta plus tan theta whole square can be expanded using the algebraic identity. It will become secant square theta plus tan square theta plus 2 secant theta tan theta plus 1 can be written as, since secant square theta minus tan square theta equal to 1, we will write secant square theta minus tan square theta here, and we will keep the denominator as it is for now, 2 into secant theta plus tan theta. Now in the numerator we have plus tan square theta minus tan square theta, which will become 0, and the remaining terms are secant square theta plus secant square theta is 2 secant square theta plus 2 secant theta tan theta divided by 2 secant theta plus tan theta. Now we are simplifying the right hand side. The right hand side has become like this, and from the numerator we can take 2 secant theta common outside. 2 secant theta into secant theta plus tan theta divided by 2 into secant theta plus tan theta. Now in the numerator and denominator we can cancel the 2. We can also cancel secant theta plus tan theta. We will get RHS is equal to secant theta, which is also our left hand side. Now the next question is also similar to the previous one. Here we need to prove sin theta is equal to p square minus 1 divided by p square plus 1. Again we will simplify the right hand side. Right hand side is p square minus 1 divided by p square plus 1. Instead of p we will substitute secant theta plus tan theta whole square minus 1 divided by secant theta plus tan theta whole square plus 1. Expanding them we will get secant square theta plus tan square theta plus 2 secant theta tan theta minus 1 can be written as secant square theta minus tan square theta divided by secant square theta plus tan square theta plus 2 secant theta tan theta plus 1 can be written as secant square theta minus tan square theta. So by multiplying this minus inside we will get secant square theta plus tan square theta plus 2 secant theta tan theta minus secant square theta plus tan square theta, and the denominator will be secant square theta plus tan square theta now we can see there is a plus secant square theta and minus secant square theta in the numerator, which will become 0, and tan square theta plus tan square theta will become 2 tan square theta, and in the denominator plus tan square theta and minus tan square theta will become 0, and secant square theta plus secant square theta will become 2 secant square theta. So the right hand side has become 2 tan square theta plus 2 secant theta tan theta, and the denominator is 2 secant square theta plus 2 secant theta tan theta. Now if we take 2 tan theta common outside from the numerator, we will get 2 tan theta into tan theta plus secant theta, and the denominator, if we take 2 secant theta common outside, we will get secant theta plus tan theta. These two terms are similar terms, we can cancel them. We can also cancel 2 and 2, so RHS is equal to tan theta by secant theta. If we write it in terms of sine and cos, we will get sine theta by cos theta into 1 by secant theta is cos theta. Cancel both the cos thetas, we will get sine theta, which is our left hand side. Hence proved. If you have any doubts in these two questions, feel free to discuss in the comment section below. Thank you.